skill. My name is Brent, and I'm here with my partner Alejandro. We're going to introduce to you today our solar cooled apparatus. Our governing motivation for this project here is high temperatures that you can see in attics, particularly in South Florida, that they can range up to temperatures of 140 degrees Fahrenheit. This will then lead into infiltrations and air leakage into the household air and drive up the AC bill from all that heat in the attic. You have a differential of up to 140 degrees versus maybe 70 degrees in your house. It's going to drive your AC bill up, and it's really not necessary to have this. Some problems that we have on modern day market are fans that are convection driven, as you see on the left here. Those do dissipate heat to a nice extent. You also have motorized fans that are consume power, so they do kind of waste a little bit of energy, and I guess they do some bit of good, but we're hoping to do a better job than these can do. Our main idea here fundamentally is to implement solar voltaic cells into the attic fans. These devices do exist currently on the market. You can pick them up at Home Depot or Lowe's. They are about $100 to $200. What we've gathered from HVAC professionals in the field is that they've never really taken off or been implemented into homes as well as they should be, because they should be working great. Another, this is completely our idea, is what we're going to do is implement a geometric photovoltaic design. It's going to be a pyramid or possibly a tetrahedral shape, and what it's going to do is it's going to maximize the surface area but minimize the volume of solar voltaic cell, and by minimizing the volume, as you can see on the house, it's going to actually open up a whole wide range of options where you can place this thing. With the current items that are on the market today, the problem is that you have to put it where the sun goes. And depending on where you live and how your house is oriented, you might have to put it here where people pull up to your driveway, or here wherever you can see it on the roof from this angle. So that's probably one of the reasons why these things haven't been implemented as widely as they should be. With ours, it should be widely available to be placed in any direction here. So you can put it behind a chimney, it's still going to get sun here or here. So that's one of the advantages of the tetrahedral shape. That, in fact, as I mentioned earlier, you can maximize your surface area while minimizing the volume, so it doesn't have to be the same like anything on your roof. In addition, the final thing that we're looking for is when you have this conical shape here, you're going to have the volume is going to decrease as the height increases here. And we're going to hope that we get a funnel-like action of the hot air being dissipated from underneath the attic and dissipate a lot quicker. So it'll give us that kind of jet-like effect, getting the hot air out of the attic quicker. The main components we're going to implement are thermistor-type technology. Essentially, they're resistors where as the temperature rises, the resistance in this case will decrease, allowing for more voltage and greater RPMs of the fan. So essentially, we'll have the hotter it gets, the faster the fan's going to spin, and hopefully the more air that will be dissipated out of the attic. This is our general design. Essentially, in the middle, that's going to be our geometric photovoltaic device, which is probably going to be the root of our problems to create. It's probably going to be the only difficult thing we're going to have doing, is to allocate the solar voltaic film on a pyramid or tetrahedral design and allow for proper current to charge the battery, which then goes to the motor, the fan. Intermittently, we're going to have electronic controllers, AC controllers, and thermistor technology. These are going to implement thermostat as well, so this thing is going to be ever-changing depending on the temperature needs by the attic. Now Alejandro's going to explain to you the global learning aspects of our project and how it involves.
All the ethics and suitability of our design, we already have on the market product relative to that we like to design. Like the company sign like air vent, blue hang, and sunlight and attic air. Both products, both companies have the products on Lowe's, Ace, or the hardware that we already found in every place. The current patent that we are trying to compete, or the current patent that is on the market, is the one that has air vent, which is this device, which is the gable-mounted power attic vent, which is a ring that they place on the attic, and has a thermostat to prevent the heat buildup, and humidity stat to prevent the humidity buildup on the attic. And the environmental impact, most of the components that we're going to use doesn't have any threat to the environment. The battery is completely rechargeable. runs on direct current. So that's allowed to use in every, it's suitable to be in any geographical location in which needs arise. For example, of some parts that we're going to use, we have the electrical controller. We convert the RPM. Also control the direction, the rotation and direction of the motor, and also works as a brake of the rotation of the motor. Then we have the transistor, which is it's a semi-conduct material. It has a very large change in resistance to a small change in temperature. Then we have a dry fan. We can find already in the market a lot of type of market, of fan, and then the motor, as you can see, the photovoltaic cells. Finally, we have this potential problem, which is to generate enough current to sequentially change the value to power.
Okay, I guess with some of the potential problems, you can all address that during our questions and ask us what our problems are going to be.
All right, so that's it. You know, you're over time.
Yeah, we'll work on it. Take some slides out of there for the next game.
All right. Go to your environmental impact slide, please. Yeah, do something about the color scheme here. The fonts are not very clear.
It's not enticing?
Well, it's not very clear sitting back here.
Okay.
Maybe better on the computer, but.
Yeah, we have a lot of glare from the lights, so
Yeah.
maybe something a little more legible.
Okay.
Okay. As long as the content is good, that's,
Yes, the content is good.
Okay.
It's good presentation. I did see a slide pertaining to division of labor and timeline.
cost of division, right. The reason for that is, we do have a timesheet already developed for our poster. We just didn't put it in here. As far as the cost sheet, we haven't ordered things yet. We're gonna have, obviously, for the presentation next week, a range of what we expect each item to oscillate to, yeah. So those two things will be our first order of business.
Yeah, so you get those on the slide for next week.
Yeah, take out some other slides, put those in.
Right.
Okay.
Technically, I don't